everybody. In this video, we're going to be talking about sample spaces and choice trees. So take 3 deep breaths and let's make this math easy. Okay, so in our last lesson, we talked about how probability can be calculated as a fraction, where the bottom number is the number of possible outcomes and the top number is the number of favorable outcomes, or the outcomes that correlate to whatever you're trying to find the probability of. So the sample space is a list of all of the possible outcomes. And it's really easy to list the sample space for experiments or situations that are pretty basic, like what we worked with in our last lesson. So for example, the sample space of rolling a 6-sided die would be the list of the possible outcomes, which are 1, 2, 3, 4, 5, and 6. If you were to list the sample space of flipping a coin, it would be heads or tails. So these sample spaces are pretty easy to find. But most of the time when we calculate probability, we're not just finding the probability of a single event happening, we're looking at the probability of multiple events happening. And when we do this, it's very helpful to use choice trees to think about the number of possible outcomes that could happen. So for example, let's say that we are spinning this spinner twice and we want to figure out what the sample space is. Well, we could use a choice tree to represent this, where the branches of the choice tree show us the different options for each of these events. So the first event, when we spin this spinner, has 5 different outcomes, because we could get pink when we spin the spinner, we could get green, we could get blue, we could get yellow, or we could get orange. So this choice tree represents all of the 5 different options I could have when I spin the spinner the first time. Then if I spin the spinner again, I could get any one of those 5 options again. So let's say that I got pink on my first time. Well, my second time could either be pink or green or blue or yellow or orange. Any one of those 5 outcomes could happen if I spun pink the first time. And same thing, if I spun green the first time, I could get pink, green, blue, yellow, or orange for my second spin. And this would basically look the same for all of these. So if I spun blue first, I could get pink, green, blue, yellow, or orange. And then same thing with yellow. I could get pink, blue, or I think I skipped green, so we'll put green in there, yellow, and orange. And if I got orange on my first spin, I could get pink, green, blue, yellow, or orange. So this choice tree represents all of the possible outcomes I could have if I spun this spinner twice. Now, if it had said spin this spinner 3 times, then I would need to have another layer of branches where each one of these would be branching off into 5 different options. Now, the reason I didn't have you do it 3 times is because that choice tree would be huge and it wouldn't fit on my slide. But however many events you have, you're going to have that many layers of branches. So in this case, we had 2 layers because we had 2 events. And we can use this choice tree to list out the sample space, because remember, a sample space is the list of all of the possible outcomes. So this branch of the choice tree is representing the possibility of spinning pink on both of the spins. So I could write that down as pink, pink. Then this branch of the choice tree is representing spinning pink and then green. This branch is representing pink, then blue. This branch is representing pink, then yellow. And this branch is representing pink, then orange. And all of those 5 options are the ones where pink was spun first. Then I could go through and do the same thing for my next set of branches, because this branch represents spinning green and then pink. This one is representing green, and so on. And so I could list those in my list. And so I'll go ahead and fill out the rest of this list, and I'll kind of speed it up so you guys don't have to watch the whole thing. Okay, so this entire list would be the sample space of spinning this spinner twice. And if you count out the number of possible outcomes here, there's 5 of them in each row, and then we have 5 rows. So there would be a total of 25 possible outcomes for this sample space. So if you were asked to say, like, find the probability of spinning 2 pinks when you spin the spinner twice, you could say, well, there's 25 possible outcomes, and only one of them is the one where you have 2 pinks. So it would be 1 out of 25. Or like you could say the probability of spinning this spinner and getting a green and a blue when you spin it, that one would be 2 out of 25 because you have 2 outcomes that involve greens and blues, and there's 25 outcomes total. So that's how you would list out the sample space. And this situation is still relatively simple, but as you can see, there's a lot of possible outcomes. And when you get into even more advanced problems where you're spinning spinners like 6 times, you don't want to have to write this all out in a choice tree, because even this relatively simple choice tree was really big. And so what you'll be doing on your assignment today is you'll be writing out the choice trees, and you'll be listing out the sample spaces. And then I also want you to show a mathematical calculation that shows how you could find the number of outcomes in your sample space without having to write the choice tree. Because today's the only day in class where I'm going to have you actually draw them out. And after this, you'll just use mathematical calculations to determine how many options are in the choice tree. So the way that we would mathematically figure this out is you're going to multiply numbers together, and the number of numbers that you'll multiply depends on how many events are happening. So in this case, we have 2 events that are happening. So we're going to have 2 numbers that are multiplied together, and those numbers are the number of options you have for each event. So for the first spinner, or the first spin of the spinner, we had 5 possible outcomes. And so the first number is going to be a 5. For the second spin, we also had 5 possible outcomes. So the second number is also going to be a 5. Sometimes it will be different though. Like if you were spinning the spinner and then flipping a coin, you might have 5 outcomes for the spinner, but only 2 outcomes for flipping the coin. So these numbers can be different, but in this particular case, they were the same because we were doing the same event twice. And the reason why you multiply these numbers together is because if you look at the choice tree, we had 5 outcomes to start with our first spin, and then each one of those branched out into 5 options. And so that made it so there were 25 branches in the tree altogether, because we had 5 branches which each branched out into 5. And so that's the reason why we multiply these. And that calculation tells us that there's 25 possible outcomes. And we can verify that because in our list, we have 25 listed items in our sample space. So that's how you would do a problem like this one. Let's do another example where we have a coin that's being flipped 4 times. So in this case, our first event is we flip the coin the first time. And we can either get heads or we can get tails. And then our second coin flip will result in either getting heads or tails. And then our third coin flip will also result in heads or tails. So notice at this stage, we're not quite done yet, but notice that there's 8 branches in this tree because we have 1, 2, 3, 4, 6, 7, 8 branches. And that's relevant to our mathematical calculation, which we'll do later. because we have 4 events that are happening, and each event has 2 outcomes. And right now we're just on the 3rd outcome, and those 8 branches can be represented mathematically with 2 times 2 times 2, because that equals 8. And then when each one of these 8 branches branch out into 2 more branches, that's going to give us a total of 16 possible, or 16 branches in our tree, which represent the 16 items in our sample space, or possibilities in our sample space. So this is what our choice tree would look like. The mathematical calculation that tells us the number of branches in that choice tree is 2 times 2 times 2 times 2, and that gives us 16 possible outcomes. And if you were trying to find the probability of, say like getting all heads, you would have some number out of 16, and that number that went on top would be the number of ways you could get all heads. So to figure that part out, let's go ahead and fill out our sample space list. So this branch of the tree is representing getting heads on the first flip, heads on the second flip, and heads on the third flip. So that would be 4 heads in a row. Then this branch of the choice tree is getting head the first time, head the second time, and head the third time, but then a tail. And so that would be another item in our sample space. And then this one would be heads the first time, heads the second, tails the third, and then heads. So we'd get head, head, tail, head. And then this one would be head, head, tail, tail. And I'll go ahead and fill out the rest of the sample space based on this choice tree, but I'll speed it up so you guys don't have to watch the whole thing. Okay, so this would be our sample space, and when you look at how many items are in it, you can see that there are 16, because if you were to count all of these up, I wrote them out in rows of 4, and you can see there's 4 rows of 4, which is a total of 16. And sometimes the list of the sample space is useful, particularly when it's hard to figure out how many outcomes are the favorable ones that you're looking to put in the top number of your probability. So earlier I mentioned you could use this to find the probability of flipping all heads. In that case, you would have 16 outcomes on the bottom of your probability, because there's 16 possible outcomes. And the only one that meets the requirement of being all heads is this first one. So the probability of getting all heads would be 1 out of 16. But if you were looking for the probability of getting exactly 2 heads, that would be a little bit different, because the outcomes that have 2 heads, there's a couple of them. So like these ones that I'm circling would be some of the outcomes that had exactly 2 heads. And there's another one. And I think that would be it. So assuming that I didn't miss one, the probability of getting exactly 2 heads if you flip a coin 4 times would be 5 out of 16. So that's one of the benefits of being able to find the sample space. So why don't you guys go ahead and try this for yourself? So suppose that you're going to roll a 4-sided die 2 times. I want you to draw a choice tree, determine the sample space, and calculate the number of outcomes in the sample space. So remember, this is a 4-sided die, which means that it only has 4 numbers on it, instead of being a regular 6-sided die that has 6 numbers on it. So go ahead and try this on your own, pause the video, and then restart it to see how I would solve this. Okay, so here's the correct answer for all of these 3 questions. So this choice tree that I've shown here on the left, that would be the choice tree that represents rolling a 4-sided die 2 times. And the list that I've shown in these rainbow colors is the sample space. And then the mathematical calculation for figuring out the number of outcomes in the sample space is 4 times 4, which gives you a total of 16 possible outcomes. So to see how I got this answer, go ahead and watch the rest of the video. And if you got the same answer as me, you can stop the video here, and I hope you have a great day. Okay, so if we're rolling a 4-sided die 2 times, the first time we roll the die, we're going to have 4 possible outcomes. So we could either get the number 1, 2, 3, or 4. So that's our first dice roll. Then if we roll the die again, the 2 dice rolls are independent. So even if I got a 1 the first time, I could still get a 1 the second time. And I could also get a 2, a 3, or a 4. So those would be the outcomes if I rolled a 1 the first time. If I rolled a 2 the first time, I could roll a 1, a 2, a 3, or a 4. If I rolled a 3 the first time, I could get a 1, a 2, a 3, or a 4 on my second dice roll. And same thing if I rolled a 4 the first time. So this would be the choice tree for rolling a 4-sided die 2 times. And the sample space can be found by listing out all of these possible outcomes. So this branch represents getting a 1 the first time and a 1 the second time. And I don't want my number to look like an 11 if I wrote the 2 numbers right next to each other. So I'm going to write it as an ordered pair with a comma and parentheses around it to distinguish that this isn't the number 11, but it's getting a 1 and then a 1. So then this next option, I have a 1 and a 2. So I'll list that one. And then for this one, I would have a 1 and a 3. For this one, I would have a 1 and a 4. And then I'll go ahead and keep doing this. So this outcome would be getting a 2 and then a 1. This outcome would be getting a 2 and a 2. This outcome would be getting a 2 and a 3. This outcome would be getting a 2 and a 4. And then this one would be getting a 3 and a 1. This would be getting a 3 and then a 2. This would be getting a 3 and a 3. This one would be getting a 3 and a 4. And then on this one, we would be getting a 4 and a 1, a 4 and a 2, a 4 and a 3, and a 4 and a 4. And so that would be the list of my sample space. And if you count up the number of ordered pairs I have in that, there's 16 of them. And we can mathematically calculate that by saying, well, I had 2 events because I'm rolling the 4-sided die 2 times. So 2 things are happening. And the first thing had 4 options, and the second thing had 4 options. And since my choice tree had 4 branches, which each branched out into 4, that made a total of 16 branches because 4 times 4 gives you 16. And so that would be the number of outcomes in your sample space.